So Nicolas Fernandez is an expert in biotechnologies in the IRD unit, and he's going to talk about GeVarLi. Thank you. So over to you, Nicolas, to start your presentation. Thank you very much, Nicolas. Thank you very much. Thank you, Nicole. So good afternoon, ladies and gentlemen. So I'm going to introduce a tool that we have developed at TransVIHMI, mostly as part of the AFROSCREEN project for the study of SARS-CoV-2 variants. But you will see that is actually more than this. GeVarLi is more than this. And our presentation is not only about GeVarLi itself, because as you can see in the subtitle of my presentation, GeVarLi, which means Genome Assembly, variant calling and lineage assignations. It's also F.A.I.R open source, scalable, modular, and no untraceable snake. So how can I introduce it? Well, I start with first of my introduction, and we'll talk about the crisis in reproducibility, the F.A.I.R notion, and some solutions to meet the specific needs of F.A.I.R. Then I will introduce GeVarLi and how you can install it and use it and look at the produced outcomes and results and its operating mode and its assets. And we'll also talk about the future of the tool and the takeaway messages as a conclusion. So as an introduction, I'd like to say that GeVarLi is the outcome of many discussions I've had with Eddie Lusama back in September 2021, where we were seeking to have a free open source tool for genome assembly. So later on, I will give you some details on how we achieved this. So back in December 2021, we had one first version of the workflow, which later became GeVarLi. So we've been using it for more than a year internally as TransVIHMI, and it's been used by our partners for AFROSCREEN. So in my presentation, I will explain why we have developed GeVarLi and how we use it, and why today we're offering it on share and how you could use it later for your own use. At the end of the presentation, so I hope the words like F.A.I.R, scalable, open source, modular, and traceable, and pipeline will be more clear to you. And if you don't know these words yet, well, I guess you'll have a better idea of what it is and how important it is. So I will start first with the crisis in the reproducibility aspect. So it's a methodological crisis that mostly affects the science, the field of science. According to the results published in scientific magazines, many things are very difficult or almost impossible to reproduce. Joanne Lady was the first to shed some light on the significance of this crisis with a paper published in 2005, Why Most Published Research Findings Are False. She was a university lecturer at the University of Stanford. He was. So he presented the pitfalls in scientific research due mostly to lack of precision and poor reproducibility. And the crisis gained momentum back in 2010, and additional articles were published. For instance, there was a call by 1,500 scientists, and there are various links available for you on this specific crisis. The question had been asked to scientists, and they had been asked if they had been able to reproduce their papers, and more than 70% of the researchers had tried to actually reproduce scientific experiments, and unfortunately they had failed to do so. It's very difficult to reproduce the experiments of your own lab, and it's very difficult to reproduce the experiments of other labs, and it mostly affects medical sciences compared to social or physical sciences. Apparently, it's due to sort of complexity pyramid. The less interaction there is on a specific phenomenon like particle phenomenon. If you see gravitational areas on the one hand, on one side of the Earth, you may not see it. But if you start focusing on social interactions between thousands of individuals, it becomes very complex. Or if you look at the interaction between thousands of proteins within the human bodies, it's very complex, and the more difficult it gets to reproduce the experiment. I wanted to add something. Oh, yeah. Sorry, I forgot. Yes, it's a problem that is quite well known, and there are many causes that we can assume. First of all, is the confirmation bias that is poorly known by scientists, and they tend to sort of mix it up with publisher perish, which that the scientists publish results that lack of positive or negative control or replications, or with statistics data that are not robust enough and not reliable. And this may be adjusted with additional means, more time dedicated to research, and also better methodologies. And make also think about scientific fraud, but you should not think that it's the main reason. It's a really minor reason. Of course, there's a lot of coverage in the media, but at the end of the day, it's quite a sort of a minor consequence. So it's mostly about the methodology. So we shall be able to adjust this quite easily. So there's a reproducibility crisis going on. So what does that mean? What is reproducibility all about? So it's quite a simple pattern, same data, same analysis, and you achieve the same results. So we can clearly see three main principles in the reproducibility process. First, the organization of the steps, and then the documentation aspects. So we often talk about documentation and documentary aspects, and many tools that I benchmark when I evaluate the tools that I may use. There's a huge lack of documentation. When people publish, they do not provide sufficient documentation on how they actually achieve their findings and results. So there are tools to help the documentation process. The second principle is about writing understandable programs with codes that may be written and proofread and worked on later on. And there are standards and conventions that may apply for good practices in this regard. We'll talk about it later. And the code has to be modular, visible, and reusable. And we'll see how we can achieve this later. And there's a third principle in the process, is actually the automation of the various steps involved. The fewer manual steps we have, the more likely we are to reduce the number of errors. So a robot will always do better than a human being. Same for computer analysis. If you have to launch the order lines one after the other, it's very likely that you make mistakes. So we'll try to boost automation in the process. So one of the key answers is what we call the FAIR principle: findable, accessible, interoperable, reusable. In French, that would translate as that the fact that the data have to be easy to retrieve, fair, accessible, interoperable in French, réutilisable, reusable in French. Fair, of course, that reminds us of the idea of équitable, fair trade, fair pay. So this is sort of idea of having a sort of generous and proactive attitude to make sure we can have easy access and easy use of the data through upstream work to make your work easier. So it's really about the open science. So the principles are detailed at the bottom right of the slide. So if you look at the icons here, what are easy to find data? Well, they're online in a database, and the database may be public or closed, but we need to have an easy access, but not for the mainstream public. So, but still, we should have easy access, but you may have to go through specific request designs, but that's very difficult. So it's almost impossible. So accessible through open access. Ideally, there's no login process. Interoperable, that means, I'll talk about this later. So, but basically, the various systems shall interact with one another according to a set of standards. So we need to have common standards in the interoperability process. So common standards for interactions. And reusable, we need to have metadata, like metadata in the raw data, as well as documentation on the coding system and comments on the codes. And also the pipeline. Once you've launched a pipeline, you have to be able to restart it again as many times as you like. And if you write your line of code yourself and launch it again, you have to rewrite the code. So it's basically, this is what we sort of promote automation. So an example of interoperable process, there are three main operating systems in all laboratories: GNU Linux, Mac OS, and Windows. And those three different operating systems allow you to have basically they are under common standards so that we can operate the three tools under the same process. If you have an analysis program that only works on Windows, you become highly dependent on Windows, or Mac if it's Mac. So I started working with a tool that is based on Unix. For GNU Linux, there is no problem. It's a unique basis and it's free and open as an operating system. Mac OS, the owners are Apple, so it's completely closed. But the good thing is that this is a unique base, that the code that I will write on Mac or Linux will work also in the native form. Windows, it's not based on Unix, but it is the owner, because it has an owner, it belongs to Microsoft, but it's becoming more and more open, more and more codes are available. And it also includes WSL for Windows subsystems for Linux. And that creates an emulation creates a Linux system within your Windows system, and you can send a Unix order that may be interpreted. So if you decide to write your own code to work on one single base, it may work also on the three available bases. It's reusable. Let me give you an example. I will talk about obfuscation. Obfuscation, what is it? Well, you can darken, scramble. So it's a information management system to sort of darken the very meaning of a message. The message is clear, but it's very difficult to understand the meaning. So this strategy may be fully intended or undeliberate. On the left, there is a code that was deliberately placed on obfuscation. So this computer code works well, but the computer cannot read the image, but it can actually read the code lines. But a human being will have a lot of difficulties to read the code because it's not clear. So why do we have this strategy in place? You may use it to protect your privacy by sort of hiding a message during an internet search. In IT or computer technologies, we often use it, it's often used in the industrial area to complexify reverse engineering. You have codes, some parts of the codes may be made public, but you don't want anybody to retrieve the specific code. So there's no point in making it open source, especially if you have an obfuscation of the code. And just a little anecdote, obfuscation comes from the Latin word prefix ob, which means in the front, and fuscar, which means dark. So you darken the whole thing. So we'll try to avoid this. Then we've talked about automation and the principle. So we try to have as much automation as we can. So I'm going to explain what a pipeline is all about. Obviously, you all know what a pipeline is. It's a transport mode for fluids like pipelines. In French, a pipeline is a tube. It's a line of tubes, of tubing. And according to computer language, it's a mechanism to have several processes so that the end of one process can be the start of the next process. So Douglas McRoy coined the concept for the Unix shells. And here we have an analogy with the pipeline. You can see here the symbol used as the vertical bar in the Unix system. So the symbol is also called a pipe. So how do we use it? Well, you type in program number 1 with entry data and you pipe it with program 2, and program 1 starts and sends the results to feed program 2. So the pipe has been mostly used in Unix. We can have dozens of orders like this one. Now, let me give you an example of a very simple pipeline, the cut-d tool, which has an impact on the access log file. And then at the end of the order, there's a sorting system with thanks to the sort tool, and then we retrieve the unique data from the access log files and replace the unique order, and then we sort again, and then we display with less. So you have a series of orders that start with the end of the previous tool. So you can see a chain of tubes, a line of pipes, a pipeline. It's a very simple pipeline, but it's an IT or computer pipeline. So if you don't know how to have this symbol, the Unicode is U plus 007 on macOS, option plus a cap plus L in capital letter. So all the software that is operated in series with various options, and all the various versions of the software is what we call a workflow. So we can have workflow of analysis. So now let me introduce a workflow FAIR example. So you can see my mouse here, the pointer. So this is how GeVarLi works. So I wanted to make sure that GeVarLi provided a fair workflow. So here you have a batch script that actually launches a tool called Snakemake, which is a pipeline manager. The pipeline manager produces some rules. So you have here a tool with specific settings. You have a configuration file where you have all the settings and all the tools, the references and the lines and so on, and codes. You also have an entry file, and the pipeline will take the entry data and forwards each entry, the fast view, into an output file where you have HTML report. So you can put it locally on your computer or on a calculation system. So this is how we can actually switch from a simple pipeline with a simple order line to a larger workflow. So let me give you more details now. So this specific workflow launches various tools, and it's quite complex to ask the user to install each of these tools because each tool requires some prerequisites. So it's not only about installing Snakemake or other tools. You need to use all the tools and orders launched in the pipeline because they're all very distinct tools. So in this regard, we'll use a specific environment manager. Many of them are available, like Anaconda on Docker. I use Anaconda, or we call it Conda in the presentation. So I'm going to introduce Anaconda. Conda is an open source environment manager. Initially, it was a packets manager for Python. You have libraries, and to install those Python packages, we used to have Conda. So it operates on Linux, macOS, and Windows, and it doesn't require any administrator access to the system. It creates a repository in the personal repository of the user, and inside of it, it will install some specific environments, and in each environment, it will install tools with some specific versions. So let me give you an example of an order. So you can create an environment called environment 1. And in this specific environment 1, you'll add a plugin 1, and then you may install R2.4, or then environment 2, where you can install plugin number 2 and R3.5, because plugin number 1 typically requires R2.4, whereas plugin number 2 requires R3.5. So there may be some incompatibility between the two plugins, but if you activate environment 1, you can call the plugin number 1 order without any problem because it's R2.4 that operates in this environment. So you create some sort of closed loops, and you may trigger those various bubbles. So you can do this outside of the workflow, and you can also include this in the workflow. So the workflow managers, many of them are quite well known. We have Snakemake, Nextflow, or Galaxy. Biologists may be familiar with Galaxy, which is a highly visual tool where you can have subsequent blocks of tools, one after the other. I also find out that Snakemake has been widely used, so I'll talk about it now. Snakemake was developed by Johannes Koester, who published an article, I don't know exactly when, I don't have the exact date, I know it was in 2012, and it was called a scalable in bioinformatics workflow engine. So after the publication of his tools, he had been very active on the forums. As soon as somebody will start using his tools, he was always there to answer queries and debug things and meet these. And it was a great pleasure to start learning to use this tool back in 2012, because we had a lot of interactions with the developer. It's very enriching. So it's a workflow manager, and we'll see later on how it works. So it is written in Python language. So you can see there's a link like Anaconda to manage the Python packages. Snakemake written in Python. I really like Python. I really like this version. So I'm very happy with this. And the great benefit is that it's very clear to read, and many libraries are actually available. So it's initially based on an IT order called GreenMake for resource management, and with also a whole set of rules. And Johannes rewrote all this, and Python plus Make is a super tool called Snakemake. So Snakemake, to start with, we'll start with the entry files, and they will write the rules, and they will be transformed in output files, and those output files will be rewritten by the subsequent tools, and you have the final finding. So you can operate it on your machine locally. You can use it also on major calculation servers. So let me give you an example of clear syntax. So the rules. So we have a series of data to create a file. So in the rule, you define the file that you want to achieve at the end of the whole processing. So this specific rule will produce a specific file. So the order and the choice of rules is directly determined by Snakemake. If you call a specific file at the output, it will look into the various rules produced and to find out what exact rule this specific file produces. Once the rule has been found, then it will look into this rule to determine what entry file it needs and to find out what rule produces this entry file in the final output files, and it traces back everything up till the entry data. We create output modules. Each rule creates at least one output file, and there will be several entry files, input files, and we will generalize the rules. We will say FASTQ Toto. We will FASTQ may be called Toto, sometimes Tata, or SARS-CoV, or monkeypox. So we can use jockers, we call them jockers. And then we will use an order called shell, where we can place all the Unix orders that produce the output files based on the input files that were fed, that were given as that were provided. We can use the run order, where we include Python codes, and then we can have several orders for features to determine the number of processes. There's a message error, log to define where the rule shall place the logs, and params to define the settings on which those tools may run. So let's find out more about it together. So together, we're going to write a rule to retrace the adventure of the Lord of the Rings, to tell the story of Lord of the Rings. So that's a Snakemake rule to recreate the adventure of the Lord of the Rings. So even though you may not be computer savvy, but doesn't matter. Let's find out more about what's written in this. What I'd like you to feel or to see is to really understand how clear the syntax is. Although you may not be familiar with Python or code, doesn't matter. Doesn't matter if it's different from what you already know. So we're going to create a variable called something, quelque chose in French, and something could be anything that's in the input repository called the Shire, la comté in French, the Shire. And inside of it, you could have something dot. So whatever the file ended with the extension .precious, this will be considered as a variable. So that's a variable that may be extended if you have 10 files that end with .precious, and something will cover those 10 files. Or you could have other variables like a media. It could be a book or a film. And somewhere else, quelque part ailleurs in French. So here we have decided that it could be Mordor or the Jaren. And we can also, because it's Python, we can define some specific functions like get episode or get episode, give me the number of episodes. So if the wildcard books, if the wildcard equals books, you get 4 episodes or 6. So if it's not book, then you create a unique rule. So you can add some comments. So it's always good to comment. You can have a number variable hard, 7 for the dwarves, 9 for the human beings, depending if it's a local server or calculation server. And there's the specific rule. Everything that's in gray is actually considered comments, so the computer doesn't care about it. So this feature will take a variable called epic final with an output format. So in the output repository and in the media sub-repository and in somewhere else sub-repository, I want you to create a something destroyed file. And media is defined as the media variable something. Something and somewhere else. So when you call this specific order, it has to retrieve each variable automatically and replaces the wildcards to produce output files. Then it will look through all the rules, the rule that actually produces this final epic, and it finds the Bilbo rules that you can comment on. The Bilbo rule, if you look at output, it does produce a final which has the same, which has the content that we want. So Snakemake automatically runs this rule because this was required as an output. So it has to apply this rule. There could be thousands, or no, not thousands, tens, dozens of similar rules. So this rule will take something input the Shire as an input file. So it will take the precious point, and then you will run a shell order with the travel adventure program with various settings, I for input, O for output. So it's a typical order for a tool with various settings, the number of episodes and so on. This may not seem very clear because you've never been involved in Python programming. Remember that we actually started from this on the right side of the screen. If you ask another bioinformatic specialist or engineer elsewhere or later in the future to try to understand this, this will appear as a lot clearer to him than this thing in white on the right. For workflow managers, we prefer this type of syntax, which is a lot more clear compared to a bash screen that was written somewhere on a computer. So when we wrote it, we understood the D variable, but here you have all the details for each variable. So this little script, you just have to type the Snakemake order, which is the Snakemake program, the environment manager. You specify what program you want to run. So the snake file example is a specific program, and you have various options, and automatically it will retrieve all the objects available in the input repository. Where there was a coffee and a ring. So you have all the possible combinations, and it's going to work on them. So you have the two entries, the coffee and the ring, that it brings to the garden in Sibir or in the Mordor as well. And it provides all possible combinations. So at the end, you have the output repository. You end up with two repositories, one for book and one for field. So in each of them available in the Mordor and garden sub-repositories, and the coffee and the ring is destroyed. So this program will run regardless of what you actually included in Precious. So where can we find these programs? Well, in the FAIR system, it has to be findable, easy to retrieve or easy to find. I use a system called Git. Git is a referencing and version control system available in open source. There are several Git platforms available. There's GitHub. So it refers to the social networks that is actually built around the Git system. And there are also others like Bitbucket, SourceForge, and GitLab. So why GitLab? I don't know if we have time to talk about it. Maybe you could talk about it at the end of the presentation if you have some questions. No? So I've collected some slides from GitHub. I use GitLab, but I will talk about GitHub. In April 2016, there were 14 million users. More than 35 million projects had been submitted. So it's the biggest host. So if you want to find source codes, you have to check GitLab or GitHub. Bitbucket is a place where you may submit collaborative codes, but it's more for the private sphere. People usually put it in private and share the code within a specific team. So it's usually not available to the public. So all these platforms that are web hosting services, and they use software version management. So you can have various versions. There are professional accounts depending on the size, or there are also free accounts available, so you can ensure access control. Who has access to it? Is it only the developer accounts, or is it the developers accounts, or the groups of users all registered, or is it fully public? So it's for the collaboration to, follow up the bugs that you may report, and then we can trace the resolution of the bugs. You can ask for new features, functions, you can manage the task and create a tool for each project. And IRD, we are lucky enough to have IRD Forge. Forge is actually a GitLab product. So GitLab is a web hosting server. They have their own server. Because this is open source and public code, we can create your own GitLab on your own server. And IRD has developed a GitLab system internally on its own servers. So maybe you don't know it, but let me introduce you Forge. So just type La Forge IRD in Google and you shall be able to find it. Here you have the direct link to it. And if you log in, you have access to all the codes that are limited to IRD users and also made public to the entire IRD. If you connect, if you log in, and if you're in a dedicated teams with various IRD teams, you may have access to the code that is dedicated to your team. You can also have access to all the codes published by IRD, available to the public for everybody. So the GeVarLi code can be retrieved from GRD. This is where I put it. It's here. So if you click on GeVarLi, I'll give you the link again. This is what you see. So you have all the various commits. Each time I submit some code and various branches, you have different tabs to explain how the tool works. And you will find the repository with all the things needed to make sure that the tool works. smoothly. So this is what you're going to have to download. And the documentation that I suggest that you shall clone the Git repository, because then you can interact more easily to have regular updates. So here you have README and GitMe. README is quite long. Wiki, sorry, Wiki. Wiki is similar to README, but it includes Wikipedia pages, so it's easier to browse. And through it, you can retrieve all the information that you need to install, use, and participate and quote GeVarLi. You may also see the issues and troubleshooting systems, so you can submit the issues you may experience and ask for resolutions. And I strongly recommend that you read the documentation, because one of the FAIR principles to solve the issue of non-reproducibility is mostly the lack of documentation. So when people write large and detailed documentation, it's it's pretty much encouraged to read the documentation, because most of the answers to your questions are actually available in the documentation. So how do we use GeVarLi? Well, I've tried to make it very simple for the non-computer savvy people. So there's a specific or common function to install Conda. So you just have to copy and paste it in a bash terminal that is available on Mac OS, Linux, or WSL on Windows. And this specific order will download the Uniconda installer, and it will suppress it. And you have Miniconda. And then you just have to clone GeVarLi. So basically, you have to download the repository of GeVarLi, and then you can browse through this. And once you're there, you can, it's only optional, but it's highly recommended that you update it, especially if you downloaded it a long time ago. And to run the program, you just have to run the bash script called bash.gevarli with the bash order. For the users who are allergic to codes, you just have to click on the script. So let me give you a live and direct demo. I'm going to share another window with you. Hold on, find that. So here you shall be able to see a GeVarLi repository. So there's a bash script that you can run in the orders, README and license. In the RITS resources, you have the FASQ. I have the FASQ for SARS-CoV-2 here, and the configuration mode, you have the configuration files to adjust the setting, depending also on the genome that you want to use as a reference, but you'll find out more later about the configuration. Oh my God, I've been talking for 38 minutes. Oh, I have to speed up. Oh, so you just have to double click on GeVarLi and it will start the pipeline. Screen sharing. I'm going to launch a line of orders so that I can share it with you. I'm in the same repository. You can see exactly what I've shown you. And I can run GeVarLi. So when it is launched, the first time you launch it, it will install all the tools that it needs with Conda. It will install all the dependencies and the system to remind you of what OS you're using, what GeVarLi version you're using, how many resources available on are available on your computer, and also the number of samples and FAST files as found, and will give you the reference that you selected in the configuration file, the minimum coverage you asked for the final consensus. and it will tell you if it runs Netscape or Pangolin, depending if Netscape or Pangolin manage. Nextel and Pangolin manage SARS-CoV-2, so the tool will be run. If you have decided to add adapters, you use clippers, and it checks that it has the right environment to start Snakemake. So in this environment, you have Snakemake. If you don't have it, it will create it. And if you already created it, it will launch it directly. It will launch a quality control process for all your samples, and it will launch all the tools for each of the samples in order to assemble your rights. So it performs the quality controls first. We have 6 samples and 12 phase queues. So I'm performing quality control on read 1 and read 2. So we have 12-time FSQ screen, 12-time FSQC, and QC tool to aggregate all the results. When it's completed, it goes directly to assembly, because it assembly, it will manage the value steps for the 6 samples. So it's currently assembling. So here we have a code error in the samples that are included negative control, neg control. So obviously, when it tries to provide statistics, coverage statistics on this sample, there's very little risk. So there's water. So there's obviously a mistake or error. So the main point with Snakemake, and it's definitely an advantage, if you have to discontinue the analysis, let's say you turn off the computer, or if there's a problem, you may restart the analysis by clicking again on the bash or putting bash GeVarLi, and it will go through the steps that haven't been launched yet. It's not a script batch with a loop that goes back, that gets back to 0 and starts again from 0. So back to my presentation now. So GeVarLi, what are the features? So we have control quality of the raw data at the end of the run process to find out if you had contaminations from other libraries. So do you have an NHTML report of the raw quality control of the samples? It cleans the sequences, it cleans the low quality bases. Optionally, it removes the primers. It aligns with the reference of your choice, with the mapper of your choice. So I use WVA. So when you assemble with those tools, you need an index of the FASTA reference, FASTA. So you have to add FASTA in the genome resource. So you add your reference in form and FASTA format in the configuration file. You have to say, specify that you want to use this file as a conference, and GeVarLi will use these depending on the mapper that you've chosen for a specific preference, and it will align with this. It will provide coverage and depth and alignment metrics and histograms of coverage. It will use the variance and creates consensus sequences, and use the various thresholds, assemble the Pangolin lineage, and ultimately, I hope to prepare. Sorry, I didn't understand. To help to facilitate the solution. So the main benefits of GeVarLi, it's free and open source. You just have to go to Forge, exactly. It's regularly updated. Netscape. It doesn't have to be connected online. So Netscape, when they perform updates, you update the tool and the databases so that it can be fully integrated in the tool. It is fair. It runs on Linux, Mac OS, and Windows because it's based on a Unix system. It works on 4 hard laptops or large calculation servers, plus 64 and so on, plus 128 gigabytes. You don't need to change the program. It works with 1 sample or as many samples as you like, with different references also for SARS-CoV-2. at the moment, we're mostly working on Ebola and monkeypox. So for the installation, you need to download Conda, then Conda installs Snakemake, and then the workflow managers downloads with Conda all the tool that it needs. And at the end of the day, if you can see, I can meet all the requirements. It's fair, open source, scalable. It can run on any type of computer or calculation server. It is modulable. You can change the cover. You can change the references. It's traceable, trackable. You have hundreds of login files and statistics at the result in the result files. If there's an error, you get an error message. So everything is trackable, and it's a pipeline. Just a few dates to remember. Back in September 2021, there were discussions with Eddie Lusamaki on will to have a free and open source software for sub-Linux analysis to find out what tools we can use to assemble the genomes of SARS-CoV-2. So I had provided a list of bibliography for the pipelines. And back in December 2021, we performed the first internal test and beta test with our partners that I would like to thank, because thanks to their feedback, we were able to troubleshoot the bugs. And there was migration, the Forge. And since April 2022, from Forge IRD had been limited to IRD people, and now it's available in the public and it's used by other people outside of IRD. In December, I introduced it during an AFROSCREEN meeting, and today it's the first time I've presented it to you. And the article is about to be finalized, and I have to submit it. So takeaway messages. Instead of remembering GeVarLi, I want you to remember the significance and F.A.I.R in computers and beyond computers, the significance of open source and free access, and the power of this tool to reproduce a full analysis with just one command order. Thank you very much for your attention. If you have any questions, I'd be very happy to answer. Thank you very much. Thank you very much, Nicolas. Congratulations for your work. Thank you very much for the presentation. So, anybody who wants to ask questions, so let me remind you, you may raise your hand or write directly your question in the discussion, in the chat box. In the meantime, I have a question. I have read that the tool is open for contributions. Could you explain how we could contribute to this? So, in README, I explained that I can take all the contributions, all the inputs that you may provide when you use or report the bugs you've come across with. And there's also maintenance needed with the updates of the tools, developing new features. And because it's a Git system, if anybody wishes to fork the tool, develop their own features and adjust bugs and then merge or simplify the updates, anything you'd like to do, just write to me and we can talk about it. As the tool is a free access with any Git account, you can develop your own features and use your own versions at home, or suggest community participation, and then we can merge your developments with the others. If it's only about updates or participation in wikis, I think the documentation dates back to November 2021. So I've developed new features since, and there's no documentation on this. So at your own level, you may contribute and participate. First question in the chat: can we install it on a high-performance cluster and use it in a job submission script?
Submission script. Okay. Ouais. Alors,
For the job submission script, well, I can answer in English. No, sure. Well, I'm translating. Because I'm translating. Hey. Okay, so I will translate you. So to install it on a high-performance cluster, HPC, yes, it is possible. And it's very likely that it is on Linux, on a Unix base. So there's no problem at all. If you do not have the administrator rights, it's not a problem because it is based on the Conda environment managers. So you don't need to ask the admin, the HPC admin, to install any specific tools or versions because the pipeline manages the installations and the tools and their various versions. Yes, you can install it without any problem. You don't need any authorization from the administrator. You can install it in your home or in a dedicated area in your calculation server. You're allowed to install it. To launch it with a job submission system, some servers, well, all servers actually are used by a lot of people at the same time. So there's a priority of task system that is sent to the server. So we have a job submission system for most servers. On each drop, we use F.A.I.R or Snakemake. For Snakemake, I find it hard. I haven't written any configuration file to automate this. So on Swarm, I use the maker. I go to the dedicated area and I launch it directly. So I don't need to go through a job submission system. And for all others, the job submission system, it works well. You just have to write the script. But I don't provide the script. And you write the script, the submission script. And Snakemake, in the configuration system of FAIR file of Snakemake, you have to specify the job submission tool that you use, and you have all the documentation on Snakemake. And Snakemake will submit the job because they manage the submission of the jobs. In the discussion, there are two more questions regarding interoperability. So sorry, with different platforms, especially if they are if they have different design, can it work? So how can you make it more interoperable with the traditional surveillance tools or monitoring tools? What do you mean when you say traditional surveillance tools? What do you mean by that? At the end, the traditional surveillance tools, so at the end, it provides a sequence, a faster sequence. It's an interoperable format. So it's standard. It's like FASQ, it's standard. And the lineage, SK, quality, everything is interoperable with Nescade, Pangolin. I don't know, what do you call traditional surveillance tools? These are interoperable formats that can be used, and the alignments are actually BAMs that are produced, and the positions are BAM files, and input files are FASQ, output files are FASTA, and reports are on HTML and AXT. All the files are interoperable with traditional standards. I can't really answer your question, I'm sorry. Thank you. And the other question, can we use it to analyze other sequences outside of virus SARS-CoV-2? Yes, of course, yes, you can. Quickly, I will share my screen again. I was on the shell. You can see the analysis of the 6 samples. It only took 6 minutes. Stop sharing. Share the screen again. That's a configuration file that you can open with any text editor or coding system. So here you can choose the number of hearts and RAM used a temporary file. Typically, I use Scratch and HPC, but it depends on what you use, the minimum cover that you wish to have and the reference that you wish to use. So here you can include the name of the FASTA file, the reference virus. In GeVarLi, I provide all the FASTA files for all those viruses. These are the ones that we use, and add your favorite genome reference here, so you can assemble with another virus called my favorite virus, mon virus préféré. You just need to have your reference. My favorite virus, mon virus préféré.fasta, my favorite virus.fasta. So in the configuration system, you align the rights from the resource files with the data of your favorite virus. In the GeVarLi file, in the source, you have the genome, and here you add your FASTA file, myfavoritevirus.fasta. And when you launch GeVarLi, it takes FASTQ, it generates an index, WVA, and you have all the FASTA there. And if you can't retrieve my favorite virus, it will index it, and then it will take the reads and align them, or the rights, with the reference. Very good. So this is how the results are displayed. Here you have all the documentation available with all the steps, the results at every step, and at the end you have the reports. So the FASTA consensus are available here, but they're available for each sample. All the cover statistics may be retrieved, but I can't share it. I can't share it here. No. All the cover statistics can be retrieved here. Lineage, pangolin lineage. Here you can retrieve all the quality controls of the raw data at HTML format. So you have all the reports if there's a bug. So if there's a bug, please report it. And then you can zip directly and send it to me by email. It's very small in size. And then I can really see where things went wrong in your system. One final smallish question, and before we wrap up, can we use GeVarLi to analyze sequences on Pseudomy Islands? Or I didn't no. Oh, the question is always on. Oh, yeah, the sequences from Minion. Well, the sequences from Minion are usually single hand and per hand, but it's not real per hand. I won't explain further. These are very long sequences with many errors, and the others are very short. The mappers and the software that take your the end of the sequencing and they try to put it in the references, the algorithms are different. So it's a different approach when you try to assemble this with millions of small pieces that are very tiny but very well detailed, or sometimes larger pieces but that are very vague, just trying to make it simple. So it's basically, I'm saying that they are very